Ouais, Shenka, c'est bon. And then we have the team leaders of the 4th, 5th, and 6th teams. So we have Georgia Virginia Panopoulou, team leader of Greece. We have Thomas Flynn, team leader of UK, United Kingdom. We have Dmitro Oleninchenko, team leader of Germany.
This case from the report, and also I would like to ask the reporter why
Juries, please show us your mark for the reporter team, the Poland. So we have 8, 9, 9, 9, 8, 7.
Some of you in the discussion missed that you had to fix the magnet. It's like super important. This maximizes the speed. This is not making your problem better. This is the solution to the problem, because your limiting factor when you do not fix the cannon is the mass of the cannon. You add balls, has more mass, more momentum goes to that and not to the final ball. It's not the magnetic energy that limits your system.
Okay. Try to do the experiment.
Oui. Si vous pouvez m'aider, merci. Thomas Flynn.
Can you go to the slide you have of your theory versus experiment, please? The green and orange one. Now, I'm curious about this because it looks like we've almost got a periodic step function in the middle. Your theory tends to match very closely on the left 3 and the right 3, but in the middle we seem to have a raising of your experimental data. This is within the error bars, but because your data matches so closely, I was wondering, do you think there's any underlying physics that could perhaps cause an oscillating step function, or is this simply an anomaly in your data?
Well, I think here we consider this only the term that there is the energy conservation, and I think we neglect all the energy losses, which can maybe explain the differences. But I think this is an agreement with the theory, so we didn't have to consider it.
If you have energy loss... Sorry.
Okay. There was, and then I will ask another question to all three of you. For the model with, instead of water, with this solid thing, could you close the presentation and try to write the Lagrangian on the blackboard? The Lagrangian was shown, but I just wonder if you can reproduce the Lagrangian that you show in your presentation, and if you can write this Lagrangian.
Is the oscillation of the water in phase with the oscillation of the bottle? Can any of you answer?
Sorry, can you repeat the question?
So is the... you showed that the periods are the same, but are the phases the same? Like when you have maximum angle, is the velocity maximum, zero?
Yes.
I mean,
well, of course, when the bottle is going on this way...
The theory is simple. You said it's simplistic or something. Well, it's great. Physics. This is exactly what physics does. Physics is reducing problems that look complex to the most important parameters and things to consider. And the fact that by identifying the right parameters and obtaining a theory which fits very well with the experiment is just wonderful. So you should not say that. I think it's unfair.